I can't. Hello, welcome back. Today we're reacting to some more Kurzgesagt. Today we have a new one. What happens if you destroy a black hole? How? How do you destroy a black hole? I can't think of a way to destroy a black hole other than by merging it with another black hole or letting it evaporate through Hawking radiation over trillions of years. How do you destroy a black hole? Oh, let's find out together.
Black holes can destroy everything.
Yes.
But can they be destroyed? What happens if we push physics to the absolute limit, maybe even
Leg!
breaking it and the universe in the process?
Okay.
Let's create a tiny black hole about the mass of our moon in the Kurzgesagt labs and try to rip it apart.
Let's do it.
Experiment 1. Nuke it.
What does
Big
that do?
booms break things. So, to set the mood,
That
let's
wouldn't-
explode the world's entire nuclear arsenal around our black hole.
That wouldn't do anything,
Black holes swallow whatever crosses their event horizon,
right?
matter
That
and
wouldn't
energy.
do anything.
And since E equals mc squared, all the energy that enters a black hole increases its mass.
Yep.
The mass of a black hole is proportional to its size, so as we nuke our tiny black hole, it just gets bigger and more massive. Experiment 2. Antimatter.
Oh, that's
Throw
an
antimatter
interesting
and
one,
light at each
actually.
other. What will happen if we throw a moon's massive antimatter at it? Unfortunately, when an object enters a black hole, the black hole will completely delete its past identity, whether it's made of matter or of antimatter. Black holes only care about gravity.
Well,
which
it's still
only
just
depends on the
energy,
total
right?
mass energy of an object.
Yep.
And the mass of a particle is the same as its corresponding antiparticle, so throwing an anti-moon has the same effect as throwing a moon. The black hole just gets more massive.
That makes
This
sense.
deleting ability of black holes is pretty interesting.
We talked
It
about
means-
this actually a little bit in one of the last videos, was the information paradox, where information must be preserved, and how there's a few theories out there on how information is preserved when information enters a black hole. Now, of course, there's still the problem of Hawking radiation and black holes dissipating over trillions of years. How do you reverse that information? But black holes are problematic.
Means that despite their size and power, black holes are, in a way, similar to elementary particles. An elementary particle like an electron is an extremely simple object, fully specified by just 3 numbers: its mass, spin, and charge. And amazingly, the same is true for black holes. They have a mass, they can rotate, and carry an electric charge.
Yes.
Once a black hole forms, it doesn't matter if it comes from a collapsed star, an anti-star, or a banana. It will always be fully described by those 3 numbers, nothing else. But if a black hole is basically a weird particle, could we destroy it with an anti-black hole?
Anti-black
Experiment 3.
holes are still black.
Anti-black hole.
An anti-black hole. So how does that impact it though? Because it's still just converted to energy, which is then converted into mass, right? So does it matter if it's an anti-black hole? I don't think so.
How exciting. A particle has the same mass as its corresponding antiparticle, but opposite charge.
It's no different than throwing
Since a black hole
antimatter
has
into a
mass
black
and
hole,
electric
right?
charge, its corresponding anti-black hole should have the same mass and opposite electric charge. What if we make them collide? Sadly, the charge will just add up and cancel out. So after the collision, we'll just get a new black hole twice as massive with no charge. Okay, we need to think bigger and stretch physics harder.
Bananas mode.
Experiment 4. Destroy the event horizon.
How?
It's true that a black hole can carry spin and charge,
How?
but even for these crazy objects, there are limits. If the spin or the charge of a black hole becomes too large, something really weird will happen. The event horizon will dissolve.
Eh?
In a simplified way, we think of black holes as hiding a singularity inside.
My understanding is that the singularity is not a physical representation, though. That the singularity is a mathematical construct to explain something that we cannot physically describe, and likely will never be able to. But the idea that there's actually a singularity or a single point with infinite density, that's how we represent it mathematically. But that's likely not how it's actually perceived in the real world.
An infinitely compressed mass with such strong gravity that absolutely nothing can escape from its surroundings, not even light. This is why a black hole looks like a black sphere of nothingness. The event horizon is the outer edge of this ultimate prison. Cross it, and you'll never be able to come back.
Yep.
But when a black hole rotates, it works a bit like a spinning washing machine. It's as if the rotation wants to repel nearby objects and push them out of the black hole, which doesn't happen because its gravity is so strong. But if the rotation gets too fast, this effect will win and the event horizon will disappear. Nearby objects won't be imprisoned forever anymore.
Because they
The
can't
same thing
enter
happens
it.
with the electric charge. Make it too large, and our ironclad jail will break open. If we manage to destroy the event horizon, the singularity would still be there, and objects would still naturally fall towards it. If you hit it, you would still die horribly and quickly. But the vicinity of the singularity won't be an inescapable prison anymore. You could get as close as you want and come back. This should count as destroying the black hole. Can we?
I having a hard time with that one, not gonna lie. I get that the effects cancel out, but there's still a point of no return. So your event horizon doesn't go away, it just shrinks. Right? Am I missing something?
We do it. Experiment 5, overfeeding. All we have to do is to overcharge or overspin the black hole. We could do this by throwing objects with a small mass and a lot of charge or angular momentum so that the charge or spin increases faster than the mass. We have to overfeed the black hole until it reaches the point where it breaks open. However, whether you can actually do this is the subject of passionate argument among physicists. Think of a charged black hole.
Yeah.
Equal charges repel each other, and the more of the same charges you squish together, the more they push back. So let's say that we have a negatively charged black hole, and we want to overfeed it with electrons, for example, whose charge is far larger than its mass. The electrons will feel an electrostatic repulsion, and the more electrons we throw, the larger the negative charge of the black hole will be, and the stronger the repulsion.
Yeah.
But once we reach the upper limit, the electrostatic repulsion will be so strong that it won't allow any more electrons to come in. At this point, the black hole will refuse to be overfed. With the spin, it's similar. Once the black hole reaches its upper limit, it won't gobble more spin. But
Would
some
that work?
scientists have discovered what looks like a loophole. If an instant before the black hole reaches the limit, we throw the right amount of matter in just the right way, it looks like we could actually overfeed it. Most scientists are skeptical, but let's give it a try anyway.
I'm quite skeptical on this.
The end? Breaking physics.
I'm also not a scientist.
There is a catch,
but
though. The event horizon of a black hole hides the singularity. So destroying the horizon would leave us with a naked singularity, one that is not hidden by an event horizon. And this poses a problem.
it still has an event horizon, though, right? The event horizon just isn't drastically bigger than the singularity anymore. It's way smaller and contained. But it's still there. There's still a point of no return. That's the event horizon. Am I missing something? Yeah.
It could mean the end of physics as we know it. There's a big dirty secret about black holes. Contrary to widespread belief, the singularity of a black hole is not really at its center. No, it's in the future of whatever crosses the horizon. Black holes warp the universe so drastically that at the event horizon, space and time switch their roles. Once you cross it, falling towards the center means going towards the future. That's why you can't escape.
The only
Stopping
thing in your
fall and
future
turning
is
back
the
would be
singularity.
just as impossible as stopping time and traveling to the past. So the singularity is actually in your future, not in front of you. And just like you can't see your own future, you won't see the singularity until you hit it. But you also can't hit something that's in your future, only sort of experience it, like you'll experience your next birthday when it
And
happens.
this is where it gets really weird.
Singularities that are in the future are not a problem because we can't see them or interact with them. But a naked singularity would be in front of us for all of us to see. What would we see? Well, the whole point is that it's impossible to know. A singularity is a region of infinite gravity, and gravity is the bending of space-time. At a singularity, the bending is so radical that the fabric of space-time is literally broken. Space and time don't exist anymore. This means that you can't predict anything, since predicting means making a forecast about where and when something will happen. But where and when have lost their meaning. So we have an unpredictable thing with infinite gravity and therefore infinite energy. This means that anything could come out of it for no reason, from a pile of bananas to lost socks or a solar system. Predictability, causality, and physics as we know it would break down. We think that singularities should exist in nature because we can prove that under very general conditions, gravitational collapse leads to the formation of singularities. However, scientists think that nature forbids the formation of naked singularities. Something enforces the creation of an event horizon around them to prevent their insanity from infecting the rest of the universe.
I guess the part that I'm still not following, and I know I've already brought this up, but the event horizon is always there, isn't it? You can shrink it, but it should always be there. The event horizon is the point that if you pass, the singularity is your future, right? There's no escape once you pass the event horizon. You can't get rid of that. You can shrink it down, but it's always going to be there, isn't it? So there's no such thing as a naked singularity. I've heard the term before, but my understanding is that it basically describes a very small event horizon due to the extreme situations that they kind of talked about earlier, right? With the overspinning and the overcharge, etc., etc. I'm a bit confused on this one, I'm not going to lie.
Without event horizons, physics may not make sense at all. So although black holes have been portrayed as the ultimate monsters of the universe, they may actually be the heroes that keep us safe from the madness of singularities. So if we do destroy the horizon, we might destroy the fundamental rules of the universe. You know what? Let's not do that.
Yeah.
Conclusion: the safe option.
Well, and the other thing too is kind of going back to the mathematics of it all. There's a lot of times in physics where we have a mathematical representation of something, but we know that that's not how it actually physically exists. It's how we represent it. And I think, correct me if I'm wrong, anybody, but I believe it's a pretty unanimous opinion that there's not actually infinite energy in a black hole. There's not actually infinite gravity. That's how we represent it mathematically, but that doesn't translate to the real world. It translates to a physicality that we probably will never actually fully understand or be able to describe because it is so extreme. But the closest that we can do to describing it is by using infinite. But infinite doesn't quite exist in a physical sense, right? So it's, I don't know.
As far as we know, there's just one safe method to destroy a black hole: wait. All black holes emit tiny particles, a phenomenon called Hawking radiation.
Yeah, we talked
This
about
process
that.
causes them to slowly lose mass until they eventually evaporate, leaving behind no horizon and no naked singularity.
Nothing.
The time it takes for a black hole to completely evaporate depends on its mass. For our mini black hole the size of a speck of dust, it will be about 10 to the power of 44 years. 10 billion trillion times the present age of the universe.
That long
So
for
is it
that
possible
small
to
of
destroy
one.
a black hole? Yes, we just have to wait. But you don't have to wait that long. There are plenty of fascinating things to explore right here on this planet right now, if you have the knowledge to understand them.
What's
to help
this?
you with that, we've created a series of lessons to take your scientific knowledge to the next level.
Is this on
Made in
Brilliant?
collaboration with
Yes.
our friends at Brilliant.org.
Oh my God, I'm
These
gonna sign up
lessons
for
give you
that.
a deeper understanding of the topics from our most popular videos, from rabies and mammalian metabolism to climate science and supernovas.
No joke. I'm going to go sign up for this after. I love these guys. But no, I'm a little confused by this one. So I get where they're coming from and I get, the whole concept of exploring this, but I don't think you can destroy a black hole other than letting it evaporate. I don't believe that there's a method that's physically possible to do that. We might be able to mathematically come up with some reasons, but I don't think that it would be physically possible. Also, I don't believe that the event horizon can go away. I don't believe that naked singularities are actually a thing. But then again, also the way that we describe black holes and the singularity within them is fundamentally flawed because it's not how it represents the physical world. So, I don't know. I got a lot of weird thoughts on this one, maybe slightly controversial, but That's how I feel. Let me know how you feel. Anyway, thank you so much for watching. I really appreciate it. If you like this content, go ahead and drop me a subscribe. It helps me out more than you can know. Have yourself a wonderful day.